Hello everyone. In today's lecture, we will learn about nitrogen rule used in mass spectrometry. It is very useful in the structure identification. So let's see in detail about nitrogen rule with examples. Nitrogen rule, it is useful in structure identification. Also, many peaks and signals that are unwanted can be eliminated by the help of this rule. The nitrogen rule is applicable for those molecules containing carbon, hydrogen, oxygen, nitrogen, sulfur, chlorine, etc. Most of the hydrocarbons and other compounds which contain carbon, hydrogen, and oxygen atoms often contain a molecular ion with an even mass, and the molecular ion which is odd, it indicates that the particular compound has an odd number of nitrogen atoms. Now let us see the examples of nitrogen rule and the rule used in mass spectrometry. So the effect of nitrogen atoms on the mass of the molecular ion in mass spectrometry is called nitrogen rule. According to nitrogen rule, if a compound contains an odd number of nitrogen atoms, then the molecular ion peak will appear at odd mass number value. Also, the compound, if contain even number of nitrogen atoms or no nitrogen atoms, that is nitrogen atoms 0, then also the molecular ion peak will appear at even mass number value. So the effect of nitrogen atoms on the mass of the molecular ion in mass spectrometry is called nitrogen rule. If the atomic mass of molecule is even, then number of nitrogen present in molecule should be even or should be 0. If the atomic mass of molecule is odd, then the number of nitrogen present in molecule should be odd. So, according to the nitrogen rule, the compound that contains odd number of nitrogen atom has a odd molecular ion and it appear at odd mass number value. And a compound that contain an even number of nitrogen atoms or zero number of nitrogen atoms has even molecular ion and having mass number value even, m by z value also even. Now let us see the examples of nitrogen rule. Now in this case, first example, benzamide. This is the structure of benzamide, C6H5CONH2. Molecular formula C7H7ON. And if we calculate the atomic mass, we get 121. That means m by z value for benzamide is 121. If we consider here, in this example, only one nitrogen is present, odd value of nitrogen atom, and the mass value, mass by Z value is also odd number. M by Z value 121, number of nitrogens odd, molecular mass is also odd. Second example, aniline C6H5NH2, number of nitrogens 1, molecular mass C6H7N 93, M by Z value 93, that is also odd number. So the atomic mass of the molecule is odd, then the number of nitrogen present in the molecule should be odd. Here one nitrogen, that is odd number of nitrogen, and M by Z value, also the molecular ion peak observed at M by Z 93 and also at 121. Both values are odd number. Third example, M-dinitrobenzene. Dinitrobenzene, that means number of nitrogens present in this example, these are 2. Molecular formula C6H4O2N2. That means 2 nitrogens. Number of nitrogens are even and the M by Z value observed, that is 92. The peak is also observed at even number value, that is 92. If the atomic mass of molecule is even, then the number of nitrogen present in the molecule should be even or that should be 0 according to nitrogen rule. Let us see the further examples. Now in this example, molecular formula is CH5N, number of nitrogens 1. If we calculate the nominal mass of this example, then carbon, number of carbon atoms 1, so 1 into 12, number of hydrogens 5, 5 into 1, number of nitrogen 1, so 1 into 14, so total we get 31. Here nominal mass is 31, number of nitrogen atoms 1, that is odd number of nitrogen atoms, and the nominal mass if we calculate, that is also observed odd number value, that is 31. In second example, molecular formula C2H6N2. If we calculate the nominal mass, that will be number of 2 carbon atoms. So 2 into 12, 6 into 1, number of hydrogens into 1 plus number of nitrogens 2, 2 into 14. So if we consider the calculation, we get 58. Nominal mass for the second example is 58. So according to the nitrogen rule, here number of nitrogen atoms 2, that is an even number. So nominal mass or the M by Z value, if we observe the peak, that is also observed at even number value at 58. So the effect of nitrogen atoms on the mass of the molecular ion in mass spectrometry is called nitrogen rule. According to the nitrogen rule, the compound that contains odd number of nitrogen atom has a odd molecular ion, and the compound that contains even number of nitrogen atoms or zero number of nitrogen atoms has a even molecular ion. Now here odd number of nitrogen atoms, so molecular ion peak or the nominal mass observed, it is also odd number. In this example, number of nitrogen atoms 2, even number of nitrogen atom, so it has a even number of molecular ion peak observed at M by Z value 58, that is even number. Now let us see important conclusion of nitrogen rule. As we have studied, the effect of nitrogen atoms on the mass of molecular ion in mass spectrometry is called the nitrogen rule. Whenever the fragmentation occurs, fragmentation, that is the cleavage, so the fragmentation at a single bond, it gives an odd numbered fragment ion from an even number of molecular ion. Also, if the odd number of molecular ion is there, that will give the even number of fragment ion. And this rule is applicable when fragmented ions contain same number of nitrogen as that of present in the original molecule. So let us see the example. First example, that is ethylamine CH3CH2 NH2 having M by Z value 45, and the second example 2,4-dinitrophenol 2,4-DNP having M by Z value 184. Now if we observe here, the first this example 2,4-dinitrophenol 2,4-DNP, the number of nitrogens present in these are two nitrogen atoms are present, and the molecular ion peak is observed at M by Z value 184. So if the atomic mass of molecule is even, then the number of nitrogen present in the molecule should be even, or that should be 0. So here two nitrogens, and molecular ion peak is also observed at 184. That is also even. Number of nitrogens present, these are 2 in this example, and this value is also even value. But if we consider the fragmentation of 2,4-dinitrophenol, so how the fragmentation or the cleavage occurs? First of all, the energetic electron is bombarded on this molecule. So the beam of energetic electron is bombarded, and there is the cleavage of this bond. So OH will be, from this the cleavage occurs, and there is a formation of a molecular ion peak, which is observed at this value M by Z 184. Further, the molecular ion is further fragmented, and there is a formation of there is a formation of a cation. H plus will be removed, and there is a formation of the cation. And if we calculate the molecular mass of this fragmented ion, that will becomes 183. That will becomes 183. Now, the number of nitrogens present in the fragmented ion and in the molecular ion, that are same, two nitrogens. Here also two nitrogens. As we have studied here, the fragmentation at a single bond gives an odd number fragment ion from an even number of molecular ion. Molecular ion peak is observed at even number value 184, but further if the fragmentation occurs, the fragmented ion and the peak is observed at M by Z value 183. But the number of nitrogens present in both in the molecular ion and also in the fragmented ion, these are two nitrogens. So this will be the first important conclusion. The fragmentation occurs at a single bond, and that will give an odd number fragment ion from an even number of molecular ion. Now let us see the another example, that is ethyl amine CH3CH2 NH2, that having the peak, observed peak at M by Z value 45. So the atomic mass is 45, and that is odd number. And if we consider here the number of nitrogens present, that are only one nitrogen is present in this ethyl amine. So again the energetic electron is bombarded on this ethyl amine, and due to that there is a formation of a molecular ion peak, and the molecular ion peak is observed due to the formation of a radical cation at the value M by Z 45. Here the number of nitrogen 1, that is odd number of nitrogens, and M by Z value is also odd number. Molecular ion peak is observed at odd value. But further the fragmentation occurs, and during that fragmentation the cleavage occurs here. So there is a cleavage of this carbon-carbon bond, so that formation of a methyl cation, there is a formation of methyl radical. There is a formation of a methyl radical, and the another cation, that is CH2 double bond NH2 plus, formation of CH2 double bond NH2 plus. And if we calculate the molecular mass of this cation, then that will becomes m by z value. Here m by z value that will be 30. M by Z value is 30. But number of nitrogens, here also one nitrogen is present in the fragmented ion, and also in the molecular ion number of nitrogens are 1. That is one nitrogen, that means the odd number of value. And if we consider this example here, the odd number of molecular ion will give the even number of fragment ion. So here CH2 double bond NH2 plus, if we calculate the M by Z value, that will be 30. So odd number of molecular ion will give the even number of fragment ion. So in these two examples, we get that whenever the fragmentation occurs, the fragmentation at a single bond, that gives an odd numbered fragment ion from an even number of molecular ion. An odd number of molecular ion will give the even number of fragment ion. And this rule is applicable only when the fragmented ions that contain the same number of nitrogen as that present in the original molecule. As we have studied here, also one nitrogen is present, and next to that in the molecular ion one nitrogen, and in the fragmented ion also one nitrogen. There are the same number of nitrogen as that are present in the original molecule. In this example, two nitrogens are present. Also in the molecular ion, two nitrogen, and in the fragmented ion also there are presence of two nitrogens. That means same number of nitrogen as that are present in the original molecule. So only when the number of nitrogens present in the original molecule and in the fragmented ion that are same, then this rule is applicable. So that is the important conclusion of the nitrogen rule. So these are two examples we have taken. Now let us see the next. Now it is the mass spectrum of ethyl amine, as we have studied. Now ethyl amine, here the fragmentation occurs and there is a formation of fragmented ion having M by Z value 30. CH2 double bond NH2 plus, that will show the peak, and that is the base ion peak, 100% relative abundance. So that is the largest or tallest peak observed in the mass spectrum of ethylamine. So it is the base peak, and if we consider this value M by Z value, it is even number, and molecular ion peak of ethylamine that will be observed at M by Z value 45. So number of nitrogens present in this ethylamine is 1, that is the odd number, and the molecular ion peak observed also at odd value M by Z value 45. But the other fragments, if we observe, most of the fragmented ions that show the peak at even M by Z value. Molecular ion peak that is observed at odd M by Z value, but most of the fragmented ions that will show the peak at even number M by Z value. So here base peak at 30, now this fragment at 28, this fragment at 26. So M by Z values of the fragmented ion that will be even number if the number of nitrogen present in the original molecule and in the fragmented molecule that will be same. So this will be the mass spectrum of ethyl amine. Let us see the another example. This will be the 4-methyl 3-pentene 2-one. In this example, if you observe, there is no nitrogen, has no nitrogen, that means number of nitrogen 0. So the mass of the molecular ion and the M by Z value for this example, it is observed here at 98. M by Z value or the molecular ion peak observed for this example is at 98. And the other fragmented ions, if you observe here, the peak of fragmented ions that show the odd M by Z value. Here, number of most of the fragmented ions show the peak at odd value 55, 43, 39, 29, 83. So as the number of nitrogens even or number of nitrogens 0, then the molecular ion peak observed at odd value, at even value, and the fragmented ions that will show the peak at odd value or M by Z value. So it is the example of 4-methyl 3-pentene 2-one. Next example. Now it is the mass spectrum of diethyl methylamine. Now in this example, there is only one nitrogen, diethyl methylamine having one nitrogen. So it shows the peak at M by Z value at 87. So it is the molecular ion peak of diethyl methylamine. So this value is odd. Molecular ion peak observed at odd value, odd M by Z value 87, and majority of the other fragment ions that are observed at even value, even M by Z value. Now if we consider the interpretation of the mass spectrum, so this peak is molecular ion peak, and the tallest peak which is having the highest intensity and arbitrarily that relative intensity is 100 is called as a base peak. So here the base peak is observed at M by Z value 72 and the molecular ion peak at 87. So we must know the interpretation of the spectrum also. So it is the mass spectrum of diethyl methyl amine. Now next one, as we have studied these two example, diethyl methylamine and 4-methyl 3-pentene 2-one. So in case of diethyl methylamine, there is one nitrogen and its molecular mass M by Z value is an odd number, and the majority of the fragment ions have even numbered masses and are even electron nitrogen cations. So that is the conclusion that diethyl methylamine has one nitrogen, that is odd value, and its molecular mass is also observed at odd number, that is M by Z 87. But most of the fragment ions have even numbered masses and are even electron nitrogen cations. In another example, 4-methyl 3-pentene 2-one has no nitrogen. So the mass of molecular ion observed at M by Z 98, which is an even number. Most of the fragment ions have odd numbered masses and therefore are even electron cations. So these two examples already we have studied in detail. Mass spectrum of each, that is diethyl methylamine and also 4-methyl 3-pentene 2-one. So in today's lecture, we have studied nitrogen rule, which is very useful in structure identification. Many peaks and signals that are unwanted can be eliminated by the help of nitrogen rule. And also we should remember it is applicable for those molecules containing carbon, hydrogen, oxygen, nitrogen, sulfur, chlorine, etc. So we have studied the few examples related to nitrogen rule. In next lecture, we will study rule of 13 and McLafferty rearrangement. Thank you.